A single U.S. Predator drone costs upward of $20 million. In contrast, an Iranian suicide drone is assembled from commercial scrap and costs a fraction of that. To protect their skies, the United States and Israel deploy the most advanced multi-million-dollar air defense systems in human history, like the Patriot missile battery. Yet on the modern battlefield, these sophisticated interceptors are regularly forced to hunt down crude, propeller-driven drones made of cheap plastic. The strategy took root in the 1980s. During a grueling war with Iraq, global sanctions completely cut Iran off from purchasing expensive fighter jets or modern spare parts. This forced Iran to adopt a doctrine called asymmetric warfare. If they couldn't outspend a wealthier enemy, they would use thousands of cheap, expendable alternatives to exhaust them. Iran prioritized recovery over invention, scavenging parts from crashed or malfunctioning Western reconnaissance drones that strayed into its territory. This effort reached a turning point in 2011, when Iranian intelligence managed to electronically hijack the RQ-170 Sentinel, a highly classified American stealth drone, landing it virtually intact. Iranian technicians systematically dismantled the captured hardware to study its internal architecture, analyzing how every single component communicated. Within years, Iran was mass-producing indigenous copies of that captured American stealth technology. By cutting off traditional arms sales, international sanctions inadvertently forced Iran to become highly proficient at military reverse engineering. Traditional military supply lines are heavily guarded and easy to block. For a sanctioned nation, accessing military-grade materials through these routes is virtually impossible. To bypass this, Iran pivoted its production entirely to consumer markets, using unregulated, off-the-shelf goods that easily cross borders. This exploded view of a Shahed 136 drone shows the result. Instead of specialized aerospace parts, it runs on a generic motorcycle engine, standard computer chips, and a carbon fiber shell. These commercial substitutions drive the total manufacturing cost down to roughly $24,000. By hacking the commercial supply chain, everyday civilian electronics have been converted into weapons that slip right through global embargoes. Once airborne, these weapons are notoriously difficult to track. They fly mere meters above the ground, and their non-metallic bodies naturally absorb radar waves. On a radar interface, that low-altitude carbon fiber design often tricks defense systems into classifying incoming weapons as a flock of birds. By the time the threat is identified, 50 cheap drones are launched simultaneously to intentionally oversaturate and overwhelm the defense grid. This creates a terminal math problem. On the left of this ledger, firing a single interceptor missile costs $2 million. On the right, the drone it destroys costs only $24,000. Forcing a superpower to burn $2 million on a scrap metal drone is a deliberate economic strike. At this scale, the goal is to exhaust the enemy's budget one interception at a time. In this scenario, the defender suffers a financial defeat every time they successfully hit a target. Today, this tactic has triggered a geopolitical role reversal. Superpowers like Russia, which once sold arms to Iran, are now purchasing Iranian Shahed drones to fight the war in Ukraine. This map highlights a 2,500-kilometer threat radius. With that kind of range, operators can strike targets across the entire Middle East without ever crossing their own borders. The economic reality of these drones has compromised the air defense calculations of the United States and Israel. Their most sophisticated systems were never designed to fight a war where they lose money with every successful hit. Global conflict is trending towards this low-cost model, where the nation with the most efficient supply chain can successfully bankrupt the nation with the most advanced technology.